Okay, on this one we are going to be converting VT graphs to DT graphs. So we've got our VT graph here, and you can see that, so there's V and T. This is negative constant velocity. It's got to be doing some serious acceleration to get up to this positive constant velocity. Then it's decelerating or slowing down to a slower positive constant velocity. The DT graph we make down here has got to represent that when we're done. So we're gonna, after we do all of the stuff, draw it, we're gonna check that to make sure it works. Now what you need to do is realize that if you're making a DT graph, you're gonna have to make a DT data table. Figure out your time frame for this first bit of constant velocity. So 0 to 5 seconds. Then we gotta figure out our second bit of constant velocity, which is gonna be from 5 to 12. And the last one's going to be from 12 to 17. Notice the overlap again, 5, 5, 12, 12. We want to figure out the distance or displacement, I guess, that each of these segments actually has occur. Since it's a VT graph, you only ever tend to get rectangles on VT graphs. So for this one, you're going to get length times width. Length is going to be 5, width is going to be minus 20. So for area 1, that there, you're going to get minus 100 meters. So for the first displacement, it's minus 100. Okay, for our second, we're going to find this right here. That's going to be length times width. That is from 5 to 12, so that's going to be 7, and up to 50. Positive 50. So that area is going to be 7 times 50, positive 350 meters. And I'm going to just do this last one first before I add anything in here. This area 3 is going to end up being length times width. That's going to be 5 times 30. So that's going to be positive 150 meters. Okay, now here's the trick on VT graphs. Your first area, you go minus 100. The next one, you go an additional minus 350, but on your DT graph, you're going to continue from there. So actually, you're going to be minus 100 plus 350 is going to be plus 250. And then for your last one, you're going to go to this 250, you're going to add on the extra 150, and you're going to be at positive 400. So there is your displacements and the time frames. Now, unless you're otherwise told that you're starting at a specific place on the displacement axis, you're always going to start at 0. We're going to start at 0. You'll notice that we also have no vertical axis here. We just have it blank, whereas we had numbers up here. So we have to add them in, and you go to here and you go, well, I'm going from minus 100 up to 400. So for these, I'm just going to go by hundreds. I'll go minus 100, minus 200, minus 300, minus 400. And for this one, I'm going to go positive 100, positive 200, positive 300, positive 400, and I guess I'll go positive 500 here, negative 500. Don't know if I need it. Well, I know I don't need it because there's only 400. All right, now here's what you do. You start off at 0. For the first 0 to 5, so you go to 5 seconds, you know that you have to be at minus 100 meters. So at 5 seconds, you map it down to minus 100, which is there, and then you use your ruler and you draw your line. So there is your first constant velocity. That's a negative constant velocity on a VT graph, and that's a negative constant velocity on a DT graph. Now from 5 to 12, at 12 seconds, you have to be at positive 250. So 250 would be right there. Pull out your ruler. You connect this, and you'll notice I'm going to leave just a little bit of space because I know that to change from negative to positive, this is going to have to be a little curled because you're going to have to accelerate up into that direction. Now, last one from 12 to 17. 17 seconds, I got to be at positive 400, which is there. And I'm going to connect that one, and I'm going to leave a little bit of space at the end so that I can do what needs to be done here, which is round. Nah, you don't really need to round them, but I did it. Now let's just make sure that this works. Negative constant velocity, negative constant velocity. Positive constant velocity with acceleration to get there. So there's your curve. There's your positive constant velocity. Then it's going to have some deceleration to get down to this positive constant velocity, which is what you show here. Fast, not so fast. Now I've kind of messed it all up by drawing, but you can kind of see what you're doing now. So that's converting a VT graph to a DT graph. There you go.